Welcome everyone to this set of lectures on Python. This is an introduction for those of you who are interested in actually using Python as a programming language for scientific computing. So what I want to walk you through are some of the very basics of how to build vectors, matrices, do logic loops, do some plotting. So this is what these first initial sets of lectures are going to be focused on, is preparing you to start doing some more sophisticated program by doing a very basic introduction. So first of all, if you've got your laptop or computer and you'd like to download Python, one of the easiest ways to do this is to go to the Anaconda website. So here's where it is, and so you just go to your browser, anaconda.com, and here what I've done is pointed it as an individual edition. So the individual edition is for personal use, and it provides a very flexible framework. And Anaconda itself is a platform which allows you to very easily install the software. As you'll see here from this page, there's a download button. So you can go to this download button, pick the kind of computer that you have, whether it's a Windows machine, Apple, so forth, download it, and that will install on your computer in the applications directory. And then what you'll see is in the application directory, there's a little icon like this, which is a green serpent, an anaconda, and you can double click that. Now what will happen is when you double click that symbol, you'll bring up is this here, which is a Anaconda Navigator. What this is a framework for a lot of different software pieces that come essentially through the Conda distribution. And what I'm going to work with here are the Jupyter Notebooks. And you can get to them by just simply pushing here, Launch. And what the launch will do is it will now execute the Jupyter Notebook, and that's what we're going to be using to do our Python program. You, of course, can write Python code directly, but Jupyter has been this amazing tool for people to do prototyping and development. It's a very nice framework to do your Python programming in. So you would hit launch here, and what's going to come up then after that launch is you will come onto something like this. It'll point you to your browser to a set of files that you might have on your computer. And for instance here, I have a set of Python notebooks, Jupyter Notebooks, that we're going to go through. And this will be part of the introductory materials for the course. In fact, all of this is available online on the website, and you can download all of these Python Jupyter Notebooks. So it'll tell you, and you can just double click on any one of these, and it will open up that file. So I'm going to start going through a few of these codes and starting to tell you how to build vectors and matrices. Vectors and matrices are going to be essentially the building blocks for all scientific computing code. And so what I want to walk through is the Jupyter Notebook here, which kind of walks through some of the ideas and how to build vectors, how to build matrices, and how to do them very nicely within this Jupyter Notebook framework. Now what you'll see here is I am actually programming here it's in a Safari browser. So what's nice about the Jupyter Notebook, it just works out of a browser. Of course, it could be a Firefox or Chrome. There's various different browsers you can use, but the Jupyter Notebook is essentially embedded in this browser architecture. Okay? So we're going to start programming some things here. Now on the top here are a set of menu items that you get directly out of this. And so for instance here, you can add cells or subtract cells. Cells are essentially the blocks in which you either have programs or you have structure in which you tell different command lines or label things. So for instance here, this cell here, I'm going to click into it. This cell is called a markdown cell. So it's just a writing. All I'm saying is section 1.1, vectors and matrices. So this is just the label I have for this architecture. You can add cells by just going here, run cells or run all, but if you want to basically build, so this is some commands around the cells you can do. If you want to add cells above or below, right, you can insert right here, insert a cell above or insert a cell below. And you can tell lots of things to be in that cell. Like the cell can be just something like words like this explaining what's going to come, or it can be actually a cell which executes a set of commands for computing some structures. Okay? So that's how you would do that. So the first one is, the first cell there was a markdown, which is just a labeling. Now we're in the second cell, and in the second cell here, this is where we're going to start spending some time. So the second cell, first of all, it's a code block. So in this kind of structure here, we have this code block, and we're going to execute some of the things that are in here. Okay? So let's start off with some basics. We're going to make some vectors, and then we're going to make some matrices. And then from there, we're going to start to learn how to manipulate vectors and matrices, and also, just within this Jupyter Notebook Python framework. So vectors are pretty easy to make. And so I've given you 3 examples of ways to make a matrix, or a vector, excuse me. And the first thing we're going to do is import NumPy as NP. So this is, NP is short for NumPy. And so this architecture, NumPy, is the architecture which actually brings in a lot of the tools that you need to do manipulations of vectors and matrices. Okay? So NumPy is basically your workhorse for doing computations. Okay? So it's going to be always in the cell where you say import NumPy as NP. We'll talk more about this later. So for instance, when you want to plot things, you're going to have to import some plotting packages as well. So everything is about bringing in packages, and then once you point to the package, then you can execute a set of code. So let's start off with what we want to do here, which is we want to execute some code which is going to just make a vector. Okay? So one way to do this is right through here. x1 is equal to, right here, 1, 3, 2. And by the way, I put all my code in night mode because I like that better. And if you want to learn how to do that, you can just go Google Jupyter Notebook night mode and walk you through. It takes like 2 minutes to do. But this is one way to define a vector. x1, you just put square brackets, commas separating the components, end it with a square bracket. There's another way to do this. x2 here is I can make an array. NP, it refers it back to the NumPy package. So NP array designates this as an array, as an object, and I can put in here, again, brackets, 1, 2, 3, and all this is in parentheses. x3 is another way to do it, which is using a matrix. Now, a vector is just a really skinny matrix. So a matrix in general can have a bunch of rows and columns. A vector is either a single column or a single row. And for here, I can do NP matrix, 1, 2, 3, and then I'm going to use the display commands right here. And the display commands, I'm going to show you what x1, x2, x3 look like. Now this is the block of code. To run it, I do ShiftReturn. ShiftReturn runs that cell. So if I do that ShiftReturn, it runs the cell, and here is the output that it just produced. 1, 3, 2, that was from x1, that's displaying x1. 1, 2, 3, this is, I guess, displaying x2, and then 1, 2, 3 are here, which is x3. So it just ran this, and it displayed those structures, okay, which is one is an array, one is a matrix, and one is just a set of numbers, which is in vector form. So these are different options that you have for displaying these structures. So I could also ask, these are going to be row vectors. So these are vectors that are essentially a single row with multiple columns. I could instead decide to make these column vectors. In other words, line up the data vertically instead of horizontally. So that would be a column vector. And so the next set of commands are around how do I make a column vector. So I'm going to use, again, the NP matrix or NP array command. And notice what I've done. The only thing different now is instead of having brackets, each row is itself bracketed. So 1 bracket, comma. That means now I go to the next row, put a 2 there, go to the next row, put a 3 there. So this is now going to create for me a vector, which is a vertical vector, or column vector, of those numbers, 1, 3, 2. You can do this also with NP array, 1, 3, 2, and I'm going to display them right here. So I display x1 or x2. These are the things I'm generating with this code. And again, ShiftReturn will run that cell, and here is the output right there. So this is what it made for me. You can see that it's in a column format. So in many cases, you're going to want to understand if you're working with a row vector or a column vector. It's very important that you understand when you're working with one or the other to make these things work. But very simple in some ways, right? You just basically can specify your vector and start to go from there. Now what I want to do is make some vectors over ranges of parameters. So what I'm going to do here is use the arange command. This is a really important command in the Python language, which is x1 here is going to be an np arange. So again, np is calling this numpy package, np.arange, and it goes from 0 to 11 in steps of 1. So what this is going to do is going to start at 0, and the 1 there doesn't make step size, so go from 0 to 11 steps of 1. So 0, 1, 2. You would think it would go all the way to 11, but it actually goes steps of 1 to a step size minus this final value. So it's going to only go to 10. Okay, so that's the way this thing counts. So it's going to go from 0, 1, 2, all the way to 10. In fact, when I display this here, right there, this is what it's going to come out to look like right here. Here's what the array looks like. It goes 0, 1, 2, 3, all the way to 10 as that type. So remember, you have to figure out how you want to count this. Normally, if you said you wanted to stop at 10, then you go one more, and then we'll stop at 10. Okay? So the arange 0 to 11 steps of 1 will go up to 10. Okay? That is just simply the architecture of the Python language. Let's go to x2 here, which is another vector. It's np arange. Go from 0 to 11, step size 2. So now it's going to start at 0, go to 2, 4, 6, 8, all the way to 10. So now your step size is 10, and again it goes 1, it goes before what this number is, and there is what that looks like. 0, 2, 4, 6, 8, 10. Okay? So you just have to put a number, if you want this to go to 10, you just have to put a number higher than 10 in there. And then it will go all the way to 10. Okay? Here's another vector we can do, np arange, 0 to 1.2 in steps of 0.2. So now you're no longer stepping in integer values, you're just stepping in values of 0.2. So you start at 0, and this goes to 1.2 in steps of 0.2, so it's going to go from 0, 0.2, 0.4, 0.6, 0.8 to 1. It doesn't go to 1.2, it goes to the one before that, which is 1. And that's what you see right here. Right here it goes from 0, 0.2, 0.4, 0.6, 0.8 to 1. Okay? So that is something that you just have to get used to in the arange. It's always going to go to, it's going to stop at the one before this final value. Let's go keep going. This one here goes from 0 to 9 in steps of 2. So it's going to do 0, 9, 2, and again, it's going to go all the way to the value of 8. So in other words, I didn't have to go to 10 and then it's going to stop at 8. I could just go anything higher than 8 if I wanted to go to 8. It's going to go 0, 2, 4, 6, 8. Even though I had 9 here, steps of 2 is going to go to the one before that, which is 8. Okay? Finally, if I do not specify a step size here, 0 to 5, what it's actually going to do if I don't specify a step size, it's going to go from 0, the step size will automatically default to 1. So it's going to be 0, 1, 2, 3, and then all the way up to 4, which is the number before 5. Okay? And so when I run this, which is again ShiftReturn, there is that vector that comes out, 0, 1, 2, 3, 4. So these are different ways to use the arange to automate the construction of vectors that you want to make and use in different configurations. Okay? A lot of times when people make these kind of vectors, you might say, I want to analyze a system that goes from time 0 to time 10 in steps of 0.2. And so you would use this kind of arange command to make a vector with all those time stamps in there and then do some analysis around that. So everything we've talked about so far are vectors. These are all vectors. And so what we want to do really though is move towards matrices, as matrices are going to be essentially the building blocks of almost everything. And one way to think about a vector is a vector, again, is just a really skinny matrix. And so there's nothing special about a vector. It is a subset of matrices. So let's go here to learning how to construct matrices. So constructing a matrix is very much like the vector, except for now we're going to use this nparray command, and we could also use npmatrix, but here I'm just using nparray. A is equal to nparray, and now you specify what you want. What I've specified here is a 3 by 3 matrix. Top row is 1, 3, 2. Next row, 5, 6, 7, and then 8, 3, 1. Okay? So they're laying on top of each other. Notice each of the rows is in brackets, and then within the brackets, commas tell me which column they're in. So this in the brackets is one of the rows. This is the next row down because I've got a comma here telling me go to the next row. And then I have another comma, go to the next row, and then what I put in here is that final row of this thing. Okay, so that's how you would construct this. So you can make this 3 by 3 matrix. Pretty easy to do. It's right there, nparray, fill in your numbers. Okay? But importantly, what I often want to do with a matrix is pull out components of the matrix. So one way to think about how this matrix is set up is that I am going to designate every position by A, I, J. I is the row, J is the column. So if I want to start pulling out pieces of that matrix, how would you do it? So I'm going to show you how to do that because that's going to be really important for us to do a lot of the scientific computing manipulations that we want to do. So here we go. For instance, x1 is equal to a 1 comma 2. So this is going to go, and remember, all the index in Python starts at 0. This is not like MATLAB, which starts indexing at 1. So when I say index 1 comma 2, 1 here refers to the second row, the 2 is the third column. Remember, we start counting. So in other words, the first component of the vector, this corner component here, is first row, first column, which is A, 0, comma 0. Okay, we're indexing starting from 0. In MATLAB, that would be A, 1, comma 1. In Python, 0, comma 0. Okay, just understand that there's a big difference between the default indexing that we have available to us. So when I say A, 1, comma 2, second row, third column. By the way, the second row is right here. Third column is that number 2. That's what's going to come out, is when we see this, it's going to come and pull that number out. Okay? What if I want to access simply the entire second row? Well, that's this command here. x2 is equal to a, go to 1, comma, colon. The colon grabs everything there. So the 1 tells you it's the second row. The colon says go grab everything. So it's going to grab this entire second row. You can do something similar with columns, which is x3 is equal to a, colon, comma 2. So it's going to go grab the third column, all of it. So the third column is I have to look at the third column of each one of these. It's 2 there, 7 there, 1 there. It's going to go grab that, and that's going to be the third column of that matrix. So very easy to essentially identify which row and column you want to pull out, or which component you want to pull out. The most important thing you have to remember is indexing starts at 0, not at 1. Okay, so let's start playing around with this a little bit. In fact, so here's when we start doing some of this and displaying some of it, we're going to display this below. And I want to talk about like this command right here. that I've highlighted. What does this mean? So A1, 0, colon 2. So what this is going to do is go A1, that means the second row, and in the second row, go grab 0, colon 2. So it's going to start at 0 in steps of 1 to 2, but it actually is one less than that. So it's 0 and 1. So the first and second columns of here is telling you the second row. Okay? So that's what that is going to pull out for us. So I can, in other words, take a small vector out of this. I want the second row. I want the first two components. This is what this command here will give us to do that. Okay? So you have full manipulation of this. And by the way, if I run this, here's what these are. And when I pulled these out, the array I pulled out there on that last one I showed you, so I think it's up here, sorry about that. Here you go. 271. All right. Actually, I take that back. That actually grabbed all of it. It actually grabbed the first 0, 1, and 2. It grabbed, in fact, everything in there. The whole second column. Okay? All right. Let's go to more complicated structures. That's just basically some manipulations. And let's go to some more interesting things to do. And I'm going to make a more complex matrix here, matrix B, and P array. And this here has, it's a 4 by 5 matrix. Actually, I count that as a 4 by 4 matrix. Okay? That was a typo up here. All right. So I built a 4 by 4 matrix. It's a little bit larger. And what I can start doing with this is start pulling out features I want of this. So for instance, X1 here, right? It's going to extract the second and third row of column 2. So column 2 is designated by that 1 right there. Remember, it's 0, 1, so it's the second column. And here, pull out 1, second and third row of that column. Okay, so when we do that, that's going to be, X1 is going to come down here. It's going to be right there, okay, when we display X1. So we've just pulled out, this counter here is pulling out 1, 2, and then it doesn't count the 3. Okay, so so the 1 indicates the second row. Remember, we start with indexing 0, and you count by 1s, but you don't go all the way to 3. Okay, here, the second ring, here, X2, it tells you, go and pull out the third row, starting from 1 to the end. Okay, but 1 here is really 2. So you start from the second column and go to the end. Okay? That's what that kind of structure tells you. Start from the second column, go to the end. And here it tells you that it's the third, it's a 3, so it's actually it's the fourth row. Okay? So remember, you start indexing at 0, so you always have to add 1 to that. There you go. This is another version of something interesting. So what this is going to do is going to pull out here from 1, let's look at the columns first, 1 to 4. So it's going to start with the second column, and it's going to second column, 1, 2, 3. So second, third, and fourth column, that's what this is going to pull out. And here, what this command structure means to you, the colon -1, is all of the rows, but not the last one. -1 means take the last one away. Okay? So it's a nice little compact architecture to say grab all the rows except the last one, and then from the second, third, and fourth column. Second, third, fourth columns. Okay? You can also concatenate and pull these things together and make another matrix out of this. So check out what I'm doing here. B0 means I'm taking the first row and from 1, colon 4, and I'm concatenating this with here, the first 0, colon 3, second column, but the column space is different, so I transpose it. That's what the dot T means. And so now I lay them on top of each other, and I've created a new matrix out of vectors out of this matrix that I have here. So when I run this, here you go, I can do that, and in fact, when I built this matrix D, which is concocted out of this, it's here at the bottom, right there. Okay, so these are just manipulations of taking data, and all I want to really represent with it is you can take matrices and you can pull pieces out, put them together in ways that you want. And this is sort of the architecture for doing it. The main thing you have to remember is when you're in this first row, first column is designated by 0, 0. You start indexing at 0 and then you go from there. And you can manipulate things as you wish. Okay, final pieces here that I want to finish with is what happens when you have complex matrices, in other words, imaginary values, and how do you do transposes. Okay, so we're going to start here with an MP array, and there it is. This is a complex number. The J there represents the imaginary part. So so you have 3 plus 2J. So this is equivalent to 3 plus 2I, where I is the square root of -1. Okay? And so that's the structure we have available to us there, and then I have some real numbers here. So one possibility is I want to take this thing, which is currently a vector, and if I want to transpose it, it's as easy as just doing dot T. So if this is a row vector, I can make it a column with a dot T. And if you want to take complex numbers and complex conjugate this, you use the MP-conj command. There it is, MP-conj x will take the J and make it a -J. So these are things you can easily do with these matrix manipulations because transposes and complex conjugations will actually play an important role in some of the data analysis that we do down the road, as well as computing down the road. You need to be able to handle complex numbers, you need to be able to handle transposes. And what I've shown you here is just how to build vectors, how to build matrices, pull things out. This whole code is just something you can download off the website. Download it, play with it. You want to be familiar with this. This is the most basic building blocks that you're going to be using over and over again for doing manipulations. And so it's really important that you become proficient and can manipulate these things very easily.